Hello, guys. It's Mrs.Z. It's a ZERN Math Student Edition, Grade 5, Mission 5, Lesson 7, and it's a problem set. Okay, here's the first question. Jeffrey built rectangular planters. Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of soil in the planter? Explain your work using a diagram. So, Jeffrey's first planter is 8 feet long and 2 feet wide. Let's see that. So length will be 8 and 2 feet will be wide, and it will be filled with the soil to a height of 3 feet in the planter. Okay, so it could be that is the planter. Let's see if the planter is 8 by 2. So if we're gonna do drawing, okay, if this is 8 feet, then wide is 2 feet. It could be that the planter is filled to the very top, which would be the height would be the same as much toilet, but because I don't know that they say the container is filled with soil to a height of 3 feet in a planter. What is the volume of soil in a planter? Explain your work using the diagram. So the planter could be even higher than 3 feet, but they want us to find how much is, so it could be that planter is the higher than 3 feet, but the soil is up to 3 feet. That's the real understanding of it. If they say that the length, the height of the platter is 4 or exactly 3 or any, then we will know exactly what is the volume, how much total of the soil can be in this platter. But let's assume that this the it did not fill all the way to the end, so like we could think that it's just a little bit less. So here they say the soil is a height 3 feet, so now this would be represents 3 feet. So this could be the soil that is inside of the planter. Okay, so if you look, it would be like here has a little bit depth left just in, and here will be the soil. All right, so now the question is, what is the volume of soil in a planter? What is the volume of soil in a planter? So now we know the length, the width, and the height of the soil. So the volume of soil is long side times shortest side times how tall is the box. When we substitute the values, we will have 8 feet times 2 feet times, oh, I forgot to put here 3, so that's 3 feet. 3 feet. So the volume of soil is 8 times 2 times 3. You can do think about base is 8 by 2, so the bottom of the box is 16. 8 times 2, 16 feet squared. So that's area of the bottom. And then times 3 feet. So what I did here, I use associative property. I multiply these two first, then multiply by 3 now. So how we can do that? We can decompose 16 into the 10 plus 6, and then we will multiply that by 3. So 10 times 3 is 30, and 6 times 3 is 18. When I add them together, they become 48. So the total soil volume is 48, but the feet squared times feet to the power of 1, or feet squared times feet makes feet squared feet. We say square feet. So that means, what that really means is that you will have a feet by feet by feet, the soil of cubes of there are feet, cubic feet. So we count how many of these cubes of the soil can fit in this prism. Okay, I hope that was understandable, and can make it smaller so you can see. It was this one, problem 1. So we're going to proceed to the problem 2. I'm going to enlarge a bit so you'll see. It says Jeffrey wants to grow tomatoes in 4 large platters. I didn't answer this question in writing, but we can also have that. I forgot to do that. So the question was, what is the volume of soil in a platter? We could use this vocabulary words to use and answer in a whole sentence. So I don't have room here, so I'm going to do it on the top. So what is the volume of soil in a platter? The volume of soil in the planter is 48 cubic feet. And that is the complete read, draw, and write strategy that we are using all the time. All right? Read, draw, write, and calculate, of course, additional, I would add. Okay. Now we can go to the number 2. Sorry. Jeffrey wants to grow some tomatoes in 4 large planters. He wants each planter to have 320 cubic feet, volume of 320 cubic feet. But he wants them all to be different. Show 4 different ways Jeffrey can make these planters, and draw the diagrams with the planters' measurements on them. So go back to this. What we need is 4 different A, B, C, and D planter. We needed to have each of planter 320 cubic feet. So each planter A, B equals B, and B equals C, and C equals D, and that all equals to 320 cubic feet. So each of these is 320 cubic feet. But he wants them all to be different. So they want the dimension to be different. Show 4 different ways Jeffrey can make these planters and draw diagrams with the planters measurement on them. So before I draw each of these, I would like let's think about how we can find one and how we can derive from that one to find the other ideas for our planters. So if this is that the volume is 300, remember volume is length times width times height. So that means the volume we already know it has to be 320 feet, cubic feet. But we need to find the three values that when you multiply them, they will give you 320. So first thing, when you think this is a multiply by 10, so it's like 32 times 10. So that's two only factors. So I have to figure it out what two multiplication factors give me, and I can create the 32. So if you know multiplication facts, you know that 8 times 4 is 23, correct? So 8 times 4 is 32. 4 times 8 is 32. And then times 10 would give me the first option of that. I can change the commutative property works for multiplication, so I can move this to be length and this to be width and this to be height, or vice versa. Okay, so that I would like to this is a first option, but I would like you to give you some idea of how we can use different strategy to find another solutions. So let's see if you have 8 times 4 times 10, and that's you do only know. So the distributive property works for multiplication as well. So you can like if I decided to do 8 times 4 times, and now I'm going to distribute 10 into two factors. I will do 2 times 5. But I needed 3 lengths, not 4. I have now 4 lengths, which I would like now to use associative property. I use distributive property, distribute 10 into 2 times 5. And now I'm going to use distributive property of multiplication, and I can multiply instead of uh, 4 times 10. I can just use associative property, and instead of I'm going to multiply 4 times 2. So now again, I will get 8 times. 4 times 2 is 8. And then instead of 10, I will have the last length will be 8. So there is another possibility of, so the first one we can use these dimensions, we can switch them around. And then the next could be this one also. Okay, so if I go back to the previous previous idea, 8 times 4 times 10, you can decompose any of these factors. I happen to be decomposing 10, but then you can decompose 8 if you liked. So that would be a 2 times 4. And then 2 times 4 times 4 times 10. Once again, you could use the different associative properties. So you could do 2 times 10, and then 4 times, and then you have 4 and 4 as for example, I'm going to give you now 2 options. So I can also do this. I can multiply 4 by 4, so I could do 2 times 4 times 4 is 16, and times 10. So that's another version of giving me 320. The possibilities are many. So what if I didn't choose to use 4 times 4? I use 2 times 10. So I can use commutative property and switch them around. Look, 2 times 10 times 4 times 4. So now instead of multiplying, I will do 2 times 10. So now this will be my 2 times 10 is 20. And then I can multiply by 4 by 4. So this is another possibility that will give me 360 320 feet cubic. So right, 1, 2, 3, 4. I can do one more. For example, let's see. If I would like to do 5 times 8 is 40. So then I will have 5 times 8, I will have a 40 times 4 times 2. If I like this solution. What I did is just instead of choosing, when I decompose 10 into 2 and 5, I choose to use commutative property and associate 5 and 8 together. 5 times 8 is 40, and then 4 and 2 will be my other factors. I hope that makes sense to you, but now you can pick and choose which we can pick and choose to be our planters. So if we like to have a long and thin platter, we could use this 40 by 4 by 2. If you like, we can also switch that around. If I like this one to be long, so 10 feet long, I could have um, 4 feet wide, and then 8 feet high if I wish. So it would be like this. So that would be the one solution. Okay, feet, feet, feet. Okay, and then we can draw how that will look like. And then this is the volume is, we know that is 320 cubic feet. Okay, now if I choose to do this one, 40, that will be very long, really long and thin. So I will take whole entire of this, and then if I choose to be 4 wide, I have to go out from that. It's okay. So 40 feet and 4 feet, and only 2 feet tall. So our platter has to be thin and long, which some depend what kind of vegetable he's gonna plant and how much water does he has, and thinks how much soil he could use this solution. And it's still 40 times 4 times 2 makes 320. So the volume is 320 cubic feet. Okay, AB, now we choose C. Maybe C, we would like to do 16, the length, the width 10, and then the height too, because commutative property works. You can switch these numbers around and you can choose which one will be your length, which one will be your width. So this, imagine if this is kind of 16 feet, and then deep is 10 feet, and then the height would be only 2. So this one will be also a thin one. I mean, the height, it won't be very tall, but it will take the most of the floor space. If you are, you can imagine this to be like that. So just in case you want a real 3D the version of this. Okay, so this will look like that, right? Okay, let's do next one. What if you like to do, which one we want to do? We did 8 by 4 by 10, 8 by 4 by 10. We did 40 by 4 by 2. We could do 8 by 8 by 5, one of these if we like. So that will be like a little more tapped and the base would be square. So if this is, let's see, if this is 8 feet, and then the 8 feet would be also the width, 8 feet, and the height would be 5. So this could look like that, right? So it's a little bit taller planter, but it also looks more, so you will have more height in the soil, and sometimes maybe that's important because it will dry, the thin will dry faster than the thicker soil. And I will be looking like this. You need it to really 3D. So 8 by 8 by 5 feet. So I told you there is so many different possibilities, but each of them will have 320 cubic feet, 320 cubic feet. Okay, our garbage truck is right here. Sorry for noise. I hope you don't hear that. And this is the number 2. I'm gonna make it smaller so you can see the whole number 2. And then we also did number 1. Okay, and we will move to back page, which is 3, 4, 3 and 4. All right, so 3 and 4, let's see what they want us to do for 3. Jeffrey wants to make one planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so it's not taller than 3 feet. Explain how you know. So he wants, if you think the picture, so Jeffrey wants to make one planter that extends from the ground to the below his window, so it's less than his window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic soil, name one way he could build the planter so it's not taller than 3 feet. It's not taller than 3 feet. Explain how you know. So the planter could be less than 3 or same as 3. So not taller than 3. So it could be 3, but not taller than 3. So when you think and draw the picture, if you imagine that this is the window, for example, just make a little tiny picture. That is the window, and then underneath he wants the platter that is going to be the flower in it. All right. So it's not gonna. Okay. So he wants this one to have the flower in there. So okay. He can plant roses or whatever he likes, right? And then the height from the ground, it's 3 feet. 3 feet. So the only where we don't know what kind of he could we don't know what length could be because we don't know exactly how long is his window as well. And then we don't know what width is also. It could be different possibilities. If you want to really make so not taller than 3 feet, so if we think that it could be 3 feet tall, then we can say that the volume has to be 36. If he wants to plant it to hold 36 cubic feet of soil, so cubic feet, the volume of the planter has to be 36. So when you think that, what possibilities are? The height has to be 3 if it's gonna be exactly. So we already know if we already know the height, then we can speculate what 2 other numbers we could have to make that solution. So if we have, for example, 3 times 3, that is 9, and then 9 times 4 is 36. That's one of the solution to get equals 36 cubic feet. If we have the volume that's also the height of 3, we could think another solution. So we could think maybe if the window is long, it could be 3 times 1 times 12. So that would be also 36, but just it will be very thin and long. If the window is very long, the platter will be thin and long and tall 3 feet. That will make 36 cubic feet. If we think about one more solution, it has a height of 3. So we know that 6 times 6 is 36. So now we know that if I want to make 36, I should have 2 6. So 3 times 2 makes 6. And then times 6 is 36. 6 times 2 is 12. 12 times 3 is 36. So that's another solution for exactly 36 feet cubic feet of the box. He wants platter to hold 36 cubic feet of soil. He could also make the height 2.5 feet, and then that will different solution. He could make, if he want to have height to be 2, then you will think about different. What if he just want a 2 feet height? So still he needs to have a 36 uh, cubic soil. So if he likes, let's see, if he likes to be height, volume equals some number times some number times 2. So now we need to figure it out what these two values would be to equal 36. So if you have 2, 2 times what makes 36. So if you cut 36, hold on, 36 into 2 parts, you have 30. Half of 30 is 15, half of 3 is 18. So so this part has to be 18. So then you can think about what kind of multiplication facts we can get 18. So they gave us, but now you can think, oh, 2 times 9 is 18. So then these could be 2 and 9 and 2. Okay, there's another 3 times 6 is 18. When you think about that, that means your possibility is 3 times 6 times 2. And that will give you again, the volume of box, 36 cubic feet. But the height is not going to be exactly 3 feet as tall is the window. It will be the 2 feet. So that will be the solution, another solution idea of it. But the volume will be 36 cubic feet. If the height is 2, if the width is that 9, and the length could be that. And then same thing here, the length, the width, and the height for each of these. All right, I hope that you like my explanation and it helps you to think. These are the good thinking skills, how to find another measurements that fits. Um, After all this gardening work, Jeffrey decided he needs a new shed to replace the old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide and 8 feet high. He realizes he needs a shade with 480 cubic feet of storage. Okay, so will he achieve his goal if he doubles each dimension? If he doubles each dimension, why or why not? That is the first question number 4. So let's see. First, if we draw that, he has 6 feet. Okay, 6 feet by 5 and by 8. So it's kind of a little bit taller than I just needed to show. This is that shade. Okay, shed. Okay, so 6 by 5 feet by 8 feet. And when we like to first find what this is original shed, the volume is 6 feet times 5 feet times 8 feet. So the volume is 6 times 5. This is the bottom of the shade, and that is 6 times 5. If you think about what the base or bottom or the top, same thing. The top is also 6 by 5, or the bottom is 6 by 5. So this is the base. That's 30 square feet, because feet by feet, feet on the power of 1, feet on the power of 1, make feet on the power of 2, times 8 feet. So when you multiply 3 times 8 is 24, and times 10 is 240. Now, square times feet is cubic feet. So when we know now that the original shed has 240 feet squared, and he wants to double it, it means that he will double the original. He needs to double original the value, so it has to go just, you can double one of the length or width, or on the height, because if you want to do double, he needs just to do 2 times 6 times 5 times 8. If he does if he does double, if he doubles each dimension, he will get shed that is 8 times greater than original, 8 times greater. What if he doubled this, it would be a 2 times 6, and then times 5 times 2 times 6, 5 times 2, and then also 8 times 2. It's going to be double the one length, double second length, and double the height, which will be making 2 times 2 times 2, 8 times greater shed. Okay. Okay. I hope that makes sense to you. So remember, if you're gonna double, you just need a 2 times 1 times 2, that whole original value. If he wants to keep the height the same, what could the other dimensions be for him to get the volume he wants? So if he wants 2 times this. So the double means the volume of his new shed would be the original times 2, which is 240 times 2, which doubled 240 is 480. So volume of new shed volume is going to be double the first one, 480 cubic feet. So we needed to figure it out how much what different ways we could get, and he wants the height to be the same. So then he could so what we needed to find volume equals, we need a length times width and times the height, that is 8 feet. So we already know that this will be 8. We need to multiply and find what would be the length and the height to be 480. So thinking of, you know that 8 times 10 is 80. So what makes what number times 8 is 48. So if you think about 6 times 8 is 48. So then I can put this to be 6 times 8 is 48. And then times 10 will give me 480. So I found what other two. It could be long 10 feet and wide 6 feet and tall 8 feet as original shed. So now when you have one dimension, it's easy to find another one by using the properties of multiplication. So 480 equals, now you think about decomposing one of those. So I'm going to do the 10 into 2 times 5 times 6 and times the height, that is 8. So I decompose 10 into 2 and 5, and then 6 and 8 stays the same. So now I'm going to use associative property. Instead of 2 times 5 makes 10, I'm going to now multiply 5 and 6. So 480 will be the same as if I do 2 times 5 times 6 is 30 times 8. So now that is another possibility. He could make 30 long feet, or too long but very wide, 30 feet wide, and the height will be 8. That's another possibility. Another possibility, instead of decomposing 10, how about if I decompose 6? So I can do that. So 480 equals 10 times, now 2 times 6. And the height has to be the same. So the height. So now commutative property, I could do commutative property, or I could do associative. So I will associate 10 times 2 is 20 times 6 times 8 are another dimension that he could use. So far we found there is also more, so you can explore on that idea. But this one is one. Another one. This one is the first one that we arrived to. So far we found the 3. If he uses dimension in a part B, what could be area of the new shed floor? So the area of new shed floor, you can see the pen 620. Okay, so messed up this one. Yes, I did. I messed up this one, guys, because I see something is wrong. If I decompose 6, I would say 2 times 3. All right. So this is my mistake. It's okay. It's good when you are working. We did so much work, so it's okay if you make mistake, and it's very plausible if you find your mistake. So I just notice that something is wrong because my brain says they have to have the same area. So 10 times 6 is 60. 2 times 30 is 60. So when I came to here, 20 times 6, that's not 60. So I saw that the pattern is not working. So that means I made mistake. So I look, I forgot to decompose 6. Instead of 2 times 3, I put 2 times 6. The same number, actually. So now you can check that I'm right. 2 times 3 is 60. So what that means is that the no matter what dimension he will use, the area is going to be always the same, 60 feet square feet. So I can show you. So the base is, this one is 10 times 6, and then you got the base, 10 feet times 6 feet, that's 60 feet squared. Feet times feet is feet squared. Okay, feet on the power 1, and makes a, so that is the base. Of course, he will do the, he will have it needed to be the height use here, but right now we are talking about area of the, what the floor that he will use. If I look this one, 2 times 30, so it would be really so 2 by 30, so the area is going to be something like this. So 2 by 30 feet, and that is 60 square feet. So it could be 10, but it's still 60 feet. This one is 20 by 3, so it could be 20 long, and then 3. So that is, and then this will be 20 feet by 3 feet, and then 60 square feet would be the area of the base of her platter, his platter. Of course, the height is always going to be the same. So because it's 8, and then 8, and then this is going to be 8. So always will be the 8, because that's what he wants. He want the height to be 8 feet. All right, so I hope this helps you understand how that works. All right, so the platter, even if I cannot stop now, guys, so bear with me. So this is actually good practice for you to see how the box, the idea of making different sheds. Like if you're gonna work somewhere in the Home Depot, or then you will explain to people what kind of boxes or sheds they could have if they but the how much area they will take is going to be the same, 60 square feet. There you go. Here you go. So they all will have 60 square feet. The bottom of, or they call that the area of the base of the sheds. Okay, guys, I think lots of work we have done. I hope you enjoy. Mrs.Z does not know how to do short work, so if you can listen to me and you can learn from me. I appreciate that. Like, so that was the B part right here. Okay. Now this one is the A part, and this was question 3 that we started, and then that will be the end. Thank you. Appreciate you.